This is lesson 2.1 on distance and midpoint formulas. So up to this point, we've only looked at equations with a single variable in it. If you'll recall, sometimes we found it useful when discussing those equations to talk about a number line. That number line was a very good model for showing what the values of that one variable could be. In this section, we're going to begin to look at equations with two variables in it. Now, we'd like to have a comparable way to look at the values of two variables simultaneously. So something similar to our number line, but allowing us to look at values of two variables at the same time. And the way that we're going to do that is using what's known as the Cartesian coordinate system. Now, hopefully we remember this. This is just our coordinate plane with an x and a y axis. We denote each point by an ordered pair. Those ordered pairs actually denote distance from the x and y axes. The x value of the ordered pair, the first one, that's actually going to tell us how far away from the y-axis the point is located. And the second value, the y value, that tells us how far away from the x-axis we're located. Now that might be seem to contradict what we commonly think about it. Usually x comma y, we think about, okay, we move along the x-axis this many and then parallel to the y-axis this many. And we'll see in just a moment, it's actually one and the same. It's just a little bit different way of looking at it. Now, folklore goes that this came about when René Descartes was lying in bed and was looking at the ceiling and noticed that when there was a fly on the ceiling that he could uniquely determine where that fly was located by measuring how far away from one ceiling and then the perpendicular ceiling, the distance from the side of the wall, that is, the distance from one side of the wall, and then measuring the distance from the adjacent side of the wall. Based on its distance from those two walls, there's no way it could be have those measures and be in more than one point. Now that's folklore. I don't think it's actually true, but it makes for a nice story. When we are looking at points in the plane, for right now, one of the easiest and simplest things that we want to do are two quick things. Given 2 points in the plane, we would like to be able to know the distance between the points, or equivalently, the length of the line segment connecting to the 2 points, as well as the location of the point right in the middle, right between the two of them. So in other words, the point that is the same distance between the two given points. So that's what we call the midpoint. So the length of that segment we're going to find using what we call the distance formula. The middle point or midpoint we're going to find using the midpoint formula. And we'll look at those in just one moment. Okay, so with our coordinate plane, we're usually going to be working with two axes, an x-axis and a y-axis. So here's our x, here's our y-axis. Now we adopt the convention that to the right on the x-axis, that is considered to be the positive direction. So anything to the right we consider to have a positive x value, and on the other hand, anything to the left we're going to consider to have a negative x value. Similarly, with our y-axis, anything up is going to have a positive y value. Anything below will have a negative y value. So for any point on this plane, so let's draw this point right here. Notice that we can measure its distance from the y-axis and its distance from the x-axis. So its distance from the y-axis would be this distance right here, and its distance from the x-axis would be this distance right here. Now we actually measure these as the x-coordinate and the y-coordinate. So it seems a little backwards that the distance from the y-axis we should call the x-coordinate. But if we think about it, That's the distance that we have traveled parallel to the x-axis, and similarly the distance from the x-axis is how far we've traveled parallel to the y-axis. So this particular point we would call x comma y, or in this particular case, notice we've traveled 1, 2, 3 along the x-axis, 1, 2 along the y. So this point we would actually call 3, comma 2. So just a quick silly example, this point right here then, we've gone to the left, so we'll have a negative x value, but we've gone up, so we'll still have a positive y value. So to the left 1, so this will have an x value of negative 1. We've gone up 1, 2, 3, 4, so a y value of positive 4. Now I'm going to zoom in on just things in the first quadrant, just for sake of simplicity. This will make our lives just a little bit easier. But this is these 2 points that we're about to examine do not have to be in the first quadrant. So I'm going to go ahead and put little hash marks here. But I don't want us to necessarily have to worry about them. Okay, so I'm going to put 2 kind of arbitrary points here. Even though this looks like the point 1, comma 2, I'm actually just going to call it x1, comma y1. And I'll put another point, say right here, that I will call x2, comma y2. Now, as I mentioned before, 2 problems that we really want to discuss here are going to be what is the length of the line segment between these 2 points, and what are the coordinates of what we call the midpoint. I'm going to just put an M here. That's the point that's in the middle of these 2. Well, we might not know how to find the distance just looking at it. However, we notice if we draw a line parallel to the x-axis, another line parallel to the y-axis, that creates a nice right triangle. We like right triangles. Right triangles satisfy our Pythagorean theorem, a squared plus b squared equals c squared. So in other words, the length of this side squared plus the length of this side squared is going to equal the length of our hypotenuse squared. So at this point here, notice that I'm going to have the same x value as this point above, the same y value as this point to the left. So the coordinates of this point are going to have to be x2, comma y1. Okay, so once again, our goal here is we really want to find the length of the hypotenuse here, the distance between x1, y1 and x2, y2. I'm going to call that distance d. So m, again, denotes our midpoint. D is the actual distance between these 2 points. Well, we know that d has to satisfy Pythagorean theorem, so if we can find the length of this side and this side, we're in good shape. Well, notice here, along this line, only our x value is changing. So that means the length of this side is actually going to be just x2 minus x1. Notice our y values stay the same between these 2 points. So the distance is just going to be the change in the x values. Similarly, between these 2 points, my x value remains the same, so the distance between these 2 points will just be the difference in the y values. So this length is just y2 minus y1. So if I put this into my Pythagorean theorem, where a is, say, the length of this side and b is the length of this side, I get that x2 minus x1 squared plus y2 minus y1 squared equals d squared. But if I want to just solve for d, let me take the square root of both sides. And that gives me the equation d equals the square root x2 minus x1 squared plus y2 minus y1 squared. And this right here is our distance formula. To find our midpoint formula, let's make some room over here. Let's think about what we would have done in just one dimension. What if we were on just our plain old number line? What would that look like? So if we are on just a plain number line, suppose we wanted to find the midpoint between 1 and 6. Well, we could count things up 2, 3, 4, 5, and just kind of eyeball what's going to be the middle. So go 1, 2.5, so it looks like maybe somewhere right in here would be the middle. So let's be 1, 2, 3, 3.5. We could eyeball it like that, but notice really what we're doing is we're taking the average here. 3.5, that's just the average of 1 and 6. So 1 plus 6 over 2, that's 3.5. So to find the midpoint on our one-dimensional number line, we just took the average of the individual numbers. In 2 dimensions, nothing really changes. To find the midpoint, we're just going to take the average of our x values and our y values. So our midpoint is going to be determined by this formula. The x value of the midpoint is just the average of the x values. The y value of the midpoint is just the average of the y values. So this is going to be our midpoint formula. So let's consider this example. Find the length and midpoint of the line segment between -2, 3 and 4, 5. Now I would recommend just it's generally not going to mess you up for this particular thing, but I would encourage you just make a little mental note. Make one of these x1, y1, the other one x2, y2. It does not matter which one is first, which one is second. What does matter is that you recognize this is x, this is y, this is x, and this is y. So don't think of these as both x's or both y's. You know that that's not true, but I encourage you to go ahead and make a little note to yourself just so that when you're trying to use these formulas, you don't mess these up. You don't get these backwards. Now, if it's helpful, if you have the formula memorized, it's going to make life a little bit easier for you if you have it memorized. And that really is the intent here. Especially for a drill quiz, you need to have this memorized. Feel free to go ahead and write down the formula. So here's our distance formula. So once I have this written down, it's now just a matter of plugging in my values. What is x2? See over here is 4 minus x1, that's -2. So I'll go ahead and write that in as -2, but that's going to be plus 2. Plus y2, I see is 5, minus y1, it's going to be 3. I want to square that. Okay, so that leaves me with 4 minus -2, so 4 plus 2, so 6 squared, plus 5 minus 3, that will be 2 squared. So square root of 36 plus 4, it's going to be square root of 40. I recognize 40 as 4 times 10. 4 is a perfect square, so I can take it out. This is going to be 2 square roots of 10. So that will be the length of the line segment, or the distance between the 2 points. For the midpoint, again, go ahead and write out the equation if you have time. So here it's just going to be the average of your x values, the average of your y values. So one common mistake here is with our distance formula, remember that we subtract these, but with the midpoint formula we add them. So here we have x1, that's going to be -2, plus x2, that will be 4. To divide it by 2. And then for my y values, y1 is 3, y2 is 5. Let's divide that by 2. So -2 plus 4, that gives me +2. 3 plus 5, that gives me 8. So I see that my midpoint is going to be at 1, 4. So my answers are the length of the line segment is 2 square roots of 10. My midpoint is going to be located at 1, 4.